Okay, so we're doing program control. Now, when I say program control, um, if you have done programming before, I mean things like if statements, for loops, that sort of thing. If you haven't done programming, you will see that as we go along here. Um, basically, what happens is you have a variable. We learned about variables in last week's video. You want your program to do something, one thing if the variable is one value, and you want to do another thing if the variable is another value. So what I'm going to do is I'm going to illustrate this idea with something called the Collatz conjecture. So let me just pull this up here. Collatz conjecture, so we know what we're talking about here. So here's what this says. We have a function. So this is a little, okay. So we have a function f of n. So you have some integer n. If n is even, you divide it by 2. If n is odd, you multiply it by 3 and add 1. So if n is odd and you multiply it by 3, then 3n is also going to be odd. So if you add 1 to it, it's going to be even. So if it's even, you divide by 2. If it's odd, you do this thing to it that makes it an even number. And then you repeat that process on this integer over and over again. Okay, so in a couple of weeks, we're going to learn more about functions in programming. But for now, Jupyter kind of allows us to do some of this stuff without functions, without having to mention functions explicitly. Okay, so here I'm going to put a comment. This actually import math. So I'm just going to run that cell there, and now I'll put a comment here. This cell will compute. And so when you do this process over and over and over again, you get a sequence of numbers. So I'm going to call it the Collatz sequence. This cell will compute the Collatz sequence for an integer n. So the Collatz conjecture says that eventually this is all going to end in a certain loop. So the Collatz conjecture says this is always going to end into the sequence 12, 6, 3, into this sequence right here, over and over again. It's always going to, or no, wait, sorry. Not this sequence, but if you have 1 and you multiply that by 3 and add 1, you're going to get 4, and then you divide that by 2, you'll get 1. So the Collatz conjecture says that all sequences are going to end in this cycle, this 4, 2, 1 cycle. Okay. And all of the numbers check to a gazillion, bajillion, whatever, follow this pattern. So any number we're going to put here is going to eventually get into this cycle here. Okay, only because we're not going to put any number that's bigger than a bajillion, gajillion, quadrillion, or whatever the biggest thing is. Okay, so this cell will compute the Collatz sequence for an integer n. And we're going to do this in a couple of videos. The first thing that I want to do in this video is to, excuse me, the first thing that I want to do in this video, I'm going to have a variable n. I'm going to call it, let's say, 15 for now. And I'm just going to show you how you can compute the next, use if statements to compute the next value of this. So n is equal to 15. I'm going to say the next, so I'm going to create a new variable that's going to be called, let's say, n sub next, and it's going to have a value. So n sub next is going to be equal something based on what n is here. So if so I want to say here if n is even. So I can't, if n is even. So Python doesn't know what if n is even means. So we're going to use the modular arithmetic, or the modulus operator. So if n divided by 2. So remember, when I use the percent thing here, you're dividing by 2 and taking the remainder. So if this is equal to 0, then we want to do something. So if this is equal to 0, we want to do something. Now it's important to keep parentheses here to make sure Python does the order of operations that we want it to do. Because what could happen is the following. We have two operations. We have the percentage operator, and we have this double equals operator. I need to tell you what both of those do. So the percentage operator is the modulus operator. You're going to do n divided by 2 and take the remainder. This double equal sign is different than the single equal sign. This is not a typo. The double equal sign is different than the single equal sign. What this means is we're going to compute the left-hand side, which is, in this case will be 1. We're going to compute the right-hand side, which in this case is just 0. The double equal sign says if those two things are equal to each other, return true. If they're not equal to each other, return false. So let me just actually come down here a little bit. So let me just give a demonstration here. So 1 equals 1. When I run this, it should say true. If I say 1 equals 0 and I return this, it should say false. Okay, so we've seen different data types in Python. Another data type is what is called these Boolean values, which are true or false. Okay, so 1 equals 0 is false. Okay, so 1 does not equal 0. 1 equals 1 is true. Okay. So what's going to happen? Let me just type out what I need to type here, and then let me explain it a little bit. So if the remainder of n divided by 2 is equal to 0, and again, I'm going to put parentheses here, and I'll talk about that in just a minute. If the remainder of n divided by 2 is equal to 0, we want to do one thing. N next is going to be equal to n divided by 2. And we need to do something different if it's not equal, if the remainder is not equal to 2. Now there's two ways we could do this. I could say else I'm going to do something. So else n next is equal to 3 times n plus 1. Whoops. Sorry. 3 times n plus 1. So this says if the remainder of n divided by 2 is equal to 0, n next is equal to n over 2, else, that is otherwise, n next is equal to 3n plus 1. Now in this case, there are two options. Either the remainder of n and 2 is going to be equal to 0, or sorry, the remainder of n divided by 2 is going to be equal to 0, or the remainder is going to be equal to 1. So that have two options. An equivalent statement would be if n, the remainder of n, if you do n divided by 2, if the remainder is equal to 1, n next is equal to that. And again, since there's only two cases, either the remainder is 0 or the remainder is 1, exactly one of these two things is going to happen. So there's different reasons to do there's different reasons to do one over the other. I prefer else here because if this is false, no matter what, this is going to happen. Sorry, I need to get rid of this. Okay, so once again, an overview of this program here. If the remainder of n divided by 2 is equal to 0, that is, if n is even, the next sequence or the next number is going to be n over 2. Else, n next is going to be equal to 3 times n plus 1. Okay, now there are several issues here that we will need to fix when we go into the next videos. But my purpose in this is just to show you how we can use if statements, the comparison operator, to make the program do the thing that we want it to. And now I'm just going to use print in next. And I want to run it like this. Okay, the last thing that I want to mention is I need to put parentheses here. I don't actually know if I need to, but it's the safe thing to put parentheses. Because if you have something like this, it's unclear. Python might do 2 equals first. It might do this first and then try to do the percentage thing. So for example, let's say 15. So 15% 2 equals 0. The output here should be false. Okay, but since it's unclear to me, this was kind of alluded to in one of the discussion questions. It's unclear to me whether Python, if I have this statement, so if I have this statement here, is Python going to interpret it this way, or is Python going to interpret it this way? Now, Python behaves consistently, and it will always do the same thing, and there's documentation that will show you what it's going to do. But the safe thing is to always put parentheses to force it to do the thing that you want it to do. So now if I run this code, we're going to get something like integer modulo by 0. Okay, so what's happening here is you might expect there's going to be an error, because if I just type in 2 equals 0, I'm going to get false. And so you might think that the error is going to be you might think that the error is going to be that you're trying to divide an integer by a Boolean value. But actually, Python and many programming languages kind of recognize true as being 1 and false as being 0. So when it does something like this, it's automatically doing stuff in the background to interpret false as 0. And so now we're doing the remainder of 15 divided by 0, which doesn't make sense. Okay, on the other hand, if I change this to 2, we're doing the modulus of 15 divided by 1, and taking the remainder, it should be 0, and that's exactly what we get here. Okay, so just a warning, whenever we have statements like this, it's best to put parentheses to force Python to do the thing that we want it to do. Now, if we didn't have the parentheses and run the code, it is going to do this modulus operation before it does the equals operation, but it doesn't always do it in the order that you want it to do. Again, it does it in a very specific way. There's documentation, but for me, the safe thing is just to put parentheses. Okay, now in the next video, we are going to, like this, we're nowhere close here to having what we need to have. Again, this is just to show you the basics of if and this comparison operator.